control centers sector. I'm here today to present MEW experience with building the geographical information system. By the way, I'm going to use the abbreviation MEW, which stands for Ministry of Electricity and Water. And here is the agenda presentation. First, I will give you introduction about MEW services and structure, and later we will see the main objectives behind building the GIS system. Also, overview about the implementation of the GIS system and some major achievements on the level of data and on the level of applications and solutions. Later, we'll see what are the main challenges that should be taken in consideration to build a stable GIS system in MEW. Also, we'll see the GIS evolution at MEW, and at the end, I will show you a demonstration from the current system. MEW is the only organization in Kuwait providing the customers with electricity and water. And also, it consists of 13 different sectors. Each sector is responsible for a specific task or specific network. And it operates, MEW operates a huge network from the generation to the distribution zone. And for this reason, we decide to have a GIS system. And the main idea of having this GIS system is to map and put all our networks on Kuwait-based map accurately and use the GIS features tools to manipulate these data. And also to integrate the system with the internal systems in MEW. Also, we can exchange these data with other entities for different reasons. The main reasons maybe will be the clearance issue. What MEW expects from the GIS, the list on the left side shows some weaknesses and disadvantages, if you want to call it, on the level of data at MEW before GIS. And the opposite list shows how can GIS remove and solve these issues. I'm gonna go over one of these issues, which is the missing data. MEW has missing data for different reasons. Maybe the main reason was most of these data lost during the war at 1990, and during the GIS implementation of GIS project, we collected these data via a field survey. And here are the main objectives behind building the GIS. First objective is to present and manage the information, both information, the spatial one and the attributes information, in accurate and fast way, and this will support the decision maker, and also will minimize the overhead on the employees or on the engineers. Also to create a centralized, to have a centralized geographical information system integrated with the non-GIS systems in MEW. And I mean here by centralized system that the data and the environment of GIS, like the hardware and other environment, are located in one central place, which is the data center, while maintaining the data is distributed on different departments according to the data owner role. Also, automate most of the business processes in MEW, which should support later the engineers during all the project life cycle, from the planning, design, implementation, until the operation and maintenance stage. And here's an overview about the GIS implementation at MEW. It's divided into five stages during 36 months, 30 months for the implementation and 6 for the warranty and support period, which is the current stage. As you know, start with the pilot project is the best way to discover any weaknesses before proceed with the complete implementation. And we started the first stage with a pilot in a specific area, and this was a really good decision. And as you know also, as you can see here, that the implementation has been delayed for 14 months. The main reason that some of the base map components, especially the parcels layer and the road of edges layers, were not ready at that time. Kuwait Municipality is the only organization in Kuwait responsible for development and maintain these data, the base map. After they prepared the base map, they provided MEW with the base map, with these layers especially, and we'll proceed with the implementation. Stage 2, we finished all the transmission network, water and the electric transmission network. And by the way, Kuwait is divided into 6 governorates. In stage 3, we finished the first 3 governorates with some of the custom apps and solutions. And on stage 4, we did the same. We finished the remaining 3 governance with some of the custom application. And now we are on the warranty and support period. Here are the major achievements on the level of data, and later we will see the major achievements on the level of application. On the level of data, as you can see here, this slide and most of the next slides will show some achievements on the level of data. As you can see here, the full extent of Kuwait base map, and here after the conversion and digitizing process for our drawings, we can see the generation zones and the transmission zones, which will support the engineers in the daily operations. And here's one of our power plant or power station, which is the Azor power station. As you can see here, we can locate and we can know the boundaries, the measurement for the power station, which will be useful in future for any expansion in future for this power station. Also, we have the attributes information which related to this power station. Also, we have different level of the voltages and the single line diagram for the whole power station, the 300 kV side. Also, we have the 132 kV side. This will be useful for the SCADA operator. In the same way, we have the primary substation. We have the single line diagram for the primaries. We have the exact location for the primaries, also the exact routes for the underground cables. As you can see here, the internal layout for the primary substation, and this on the transmission network. Also on the transmission network, we can see the overhead lines with the attributes information related to this overhead lines. By the way, the locations of the overhead lines has been collected via field survey during the GIS implementation. It wasn't exist before that. And here, before and after for one of our assets on the transmission network, which is the primary substation, one of our primaries. This is the older drawing, as you can see. It doesn't show the, it's not georeference. It doesn't show the exact location of the primary, even the exact routes for the underground cables. And here after the GIS, you can see the exact location for the primary georeference. You can see the exact routes for the underground cables. Also, you can use different tools and smart tools, powerful tools from Esri or ArcFM, because this system is based on ArcGIS and ArcFM. And here the process of conversion for one of our assets, which is the Doha wastewater desalination plant. We use the georeference satellite image with the AutoCAD, georeference AutoCAD, and we digitize the main assets inside the power plant. In the same way, on the water network, we have the reservoirs after the conversion process, transmission pipes, and here before and after the conversion process for the water network. GIS is not just a geographical information system that generate or give the spatial view. Also, different statistical charts can be generated from the GIS. As you can see, we have here different 3 figures. In figure 1, on the transmission network, we can see statistical chart for the main assets on the transmission network, like the overhead lines, underground cables, transformers, and so on. Also, in figure 2, we can see the circuit length for the conductors, for the overhead, number of towers. Figure 3 shows the transformers by megavar rating. In the same way, for the distribution network, for water network, we have different statistics, and also for the communication network. Now, major achievements on the level of business solutions or custom applications or even the integration. The target of MEW to build and develop different custom applications according to the business needs of MEW departments or MEW engineers, and to support the engineers in the daily operations and also during all the project's life cycle, from planning, design, implementation to the operation and maintenance for these assets. Also to integrate the system, the GIS system, with the non-GIS systems in MEW especially the real-time systems like SCADA and others, to have the optimum solutions and to improve the utilizations of these systems in one system without any duplication. And here are some examples of these business solutions or integration. On the planning level, we have interface with system called central system to calculate the load flow spatially. And this will be useful for the expansion for the network in future. Maybe the next presentation I can show you in details this application. Now I'm just showing you the experience of MEW with building the JS system. And also in the design phase, we have the clearance. We have different applications. We have the clearance application. This application, the aim of this application is to give or to generate clearances for other entities in automated manner. And this will accelerate the implementation of all the projects inside Kuwait. Also, we have the water facility siting application. This application will help the water distribution design engineers to identify the best connection to the existing water distribution network. And also we have the EFS application, the electricity facility siting application. In the same way, will provide the electric engineers with different scenarios from which they can choose the optimal connection in automated manner also. By the way, I'm IT electric engineer. I'm the project manager for the implementation of JS, but I have team from different sectors, from the transmission, distribution, from the water, from the substation, power station. And later, if you want to ask, maybe you can ask me just about the application side. Also in the business solutions, we have on the construction level, we have a project tracking application. To track, the main idea of this application is to track the MEW projects especially. And also you can locate and you can generate different reports by engineer, by project engineer, by governance if you want. It's a powerful application. On the operation and maintenance level, we have the outage management system to locate the outages and repairs. And some of these applications, we are trying to activate them immediately right now. Yeah. Especially the most important application, which is the clearance, because it will be published for the public. And now there are three main challenges, as I see, to make the JS stable system immediately. The first one is the system update. You have to keep your system updated, especially the JS. You know, any JS system to be, it measured the value of the JS system by its up-to-date factor. And to keep our system updated, we have to maintain the following 4 points, especially in MEW. First one, the base map availability, because we are not the owner of the base map. The owner of the base map is Kuwait municipality. And they provided this base map during some link. It should be up and running all the time. Also the network connectivity issue, especially for the editors, because the editors for the JS system are distributed in different locations in Kuwait, which makes the connectivity issue more complicated. Also applying data collection workflow, especially the field survey process, it's not an easy process. It needs trained, qualified people. Capacity building, this one is an essential issue, especially for the new users who join the MEW. We have to make sure that they are aware and ready to use the JS and to know everything in the JS environment. The second challenge, as I see, is the change management issue. As you know, people who used to do their works with the traditional way, with the old systems, reject all the time any new system. I think this retains to the mentality of these people. We are trying to convince them, we are trying to explain to them the benefits of the new systems versus the old systems, also with having support from their top management to provide us with dedicated people for the JS system, especially for the editor role. And here's the third challenge, and in my opinion, this is the most complicated one: the integration with other systems immediately, for many reasons. The first reason, some of these applications or systems are closed systems, like SCADA systems. It's not allowed to do direct integration with these systems, which needs more workarounds and more efforts. Also, some of these systems in EW are not ready yet. Some of these systems are legacy systems, which creates compatibility issue during the integration. Our target in EW, inshallah, is to build a stable JS system integrated with internal system in EW and exchange these data with other organizations, government organizations, or even the private sector to have a smart grid ready, inshallah. And here's a demo. I can show a demo. I have different scenarios, but maybe I will have only today. I can show you just one scenario. It's from the desktop application. It's I'm going to use here. We are using the powerful tool, which is the downstream tracing from on the feeder pillar on the street light network from one of the circuits. It will show you the street poles connected to this circuit, and also the attributes information related to these street poles. And also I had different scenarios, but because of the time, I think I exceeded my time.
Oh, it's okay.
It's okay.
That's good.
Thank you.
Okay, thank you very much for your presentation. So we have